Hello everyone, welcome back. In this video tutorial, I'm going to introduce a new barometer or pressure sensor that will be MPL115A2. And let's go to the website controleverything.com, and here on we have to search on for this particular sensor, and it's a digital barometer 5215 kilopascal I2C Mini Module, and more features are on this screen as you can see, and you can also purchase the sensor right from here. Also, I will be interfacing the digital barometer MPL115A2 with a Beaglebone Black and the C language code. And let's go to resource tab, and here we have the C code sample onto the screen, and you can download the code sample as a zip file from here. And also you can get the code from github.com, and the repository there will be Control Everything community. Now let's proceed further and make some hardware connections for the video tutorial. Well, for the hardware connection setup, the first thing we require is the Beaglebone Black, which you are able to see on my screen. And this here is an I2C Shield for the Beaglebone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what do we require is to gently place this I2C Shield over the Beaglebone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this, and gently insert it over here. It is very useful to power up the Beaglebone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. Now this here is our barometer MPL115A2, and this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly to the ground of I2C Shield. So we are done with the hardware connections. Now let's proceed with the interfacing of the code. Well, in the interfacing part for the code, we need to log into github.com, and thereafter we have to search on for the repository that will be Control Everything community. Getting there, we have the sensor that will be MPL115A2, and this here is the C code. But let's have a look over the instructions part. We need to set up the Beaglebone Black, and the steps are on this link, beaglebone.org. And when I open the link, you can see a lot of steps that need to be overtaken for the instructions for the setup part. Please do it carefully. After getting that, we have to download or git pull the code onto the Beaglebone Black, and this command will compile, and this will run the C program. Now get back to the C code, and as you notice, it's a .c extension file. First of all, in the code we have included some of the header files and the libraries, and in the void main function we are going to check whether the I2C bus is going to open or not, and the address of the I2C device is 0x60. Now in this part we are going to read some of the coefficients, as you can see, for the compensation purpose, and here we are reading 8 bytes of the data from the address 0x04. After that we are going to convert the data to floating points, and here we have used some of the formulas which were mentioned in the data sheet for MPL115A2. After that we are going to send a command, as you can see, writing part. Here we are going to send pressure measurement command 0x12, and we are going to start the conversation that will be 0x00. Here it is, and then we have to read 4 bytes of the data from the register 0x00. It is the pressure and temperature data, and here we have the conversion of the data, as you can see, for the pressure and the temperature, and here we have used the formulas and the functions we have used in the datasheet for MPL115A2. It is clearly mentioned there. At the very end, we have the output data onto the screen, which is the pressure in kilopascal and temperature in Celsius and Fahrenheit units. So this is how the code is. Now let's see how it works. Let's have a look over the working part, which is very interesting in itself, and for that thing we need to copy the entire code, as you can see. And here we have to create a new file, as you can see on my screen. This is the part for that. .c will be the extension, and here in this file we need to paste the entire code we have just copied, and after that we need to save it. That's correct. Now for the compilation, this is the whole command, and here we go with the compilation step, and the code has been compiled successful. But instead, when I try to run the code, and this is the command for that, and here we have the pressure in kilopascal and temperature in Celsius and Fahrenheit. And when I again run it, the changes are onto the screen, which you can notice on my screen. So this is how the changes are there. But when I try to apply some pressure over the sensor and run the command, we have the pressure changes, we have the temperature changes in Celsius and Fahrenheit. And when I again run the command, you can see a significant change onto the screen. So this is how the sensor works. Now let's have a look over the applications and some of the benefits. The MPL115A2 is an absolute pressure sensor with a digital I2C output targeting low cost applications. The MPL115A2 employs a MEMS pressure sensor with a conditioning IC to provide accurate pressure measurements from 50 to 115 kilopascal. An integrated ADC converts pressure and temperature sensor readings to digitised output via an I2C port. Factory calibration data is stored internally in an onboard ROM. The typical applications for this sensor are barometry, altimeters, weather stations, hard disk drives, industrial equipment, health monitoring, air control systems. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com. And to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.